Hi everyone, my name is Yogesh P, and in this video I'm going to present a project titled Microcontroller Based Washing Machine Simulation using picsimlab, developed as a part of Embedded System Internship under emertxe. So, introduction to the project. So, in this project we are developing a washing machine simulation using picsimlab. Washing machine have a great impact in a modern society. Washing machine is the machine used to wash the various types of clothes without applying any physical effort. Automatic machines may wash, spin, and heat in a cycle. Presently, we can find a variety of washing machines, particularly fully automatic ones, which are the front runners in terms of client demand. Users can enjoy fully automatic machines than semi-automatic machines. We built a simple washing machine spin timer using PIC16F877A microcontroller. Microcontroller and microprocessor are used to control various electronic operations such as monitoring systems, controlling systems, and driving the systems. These are the things that we learned during the duration of this internship, which is C program is one of them. The main topics that we covered under C programming are number systems, which contain binary, octal, decimal, hexadecimal number system, and data representation in the form of bits, bytes, and words. Under data type, we have integral data type and floating data type. Integral data type consists of int and char data type. Int data type is capable of holding 4 bytes and char data type is capable of holding 1 byte. Under floating point, float data type is also capable of holding 4 bytes of data. Double data type is capable of holding 8 bytes of data. In the operations, we have learned various arithmetic operation, bitwise operation, and other logical operation. Coming to the arrays, arrays are contiguous blocks of memory containing same type of data. And coming to the functions, functions are the blocks of code which perform particular tasks. Functions is the process of coding. We can call the function as many times as possible, and the same function can be called multiple times in recursive manner. And next is strings. Strings are nothing but character arrays which are used to store words and other text type data. And we have storage classes which we use like auto, register, static local, static global, and extern. And the next thing that we learned are pointers. Pointers are special type of variable which holds the address of other variable. Using that address, it can point to the address of that variable, and we can perform many operations like modification of the data or increment or decrement operation as per our needs. And the next thing we learned is about microcontroller and microprocessor. Microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. All components in a single chip and less design complexity. Microcontrollers can take inputs from device they are controlling and retain control by sending the device signals to different parts of the device. Microprocessor, on the other hand, contains the arithmetic logic and control circuitry required to perform the functions of a computer's CPU. We need to connect peripherals externally, so it makes the circuit little bulky compared to microcontroller as there is lot of external connections involved. Due to external components, the total power consumption is high. Therefore, it is not ideal for devices running on stored power like batteries and especially in embedded systems. So microcontroller is majorly preferred in embedded systems development. Next, we learnt about need of microcontroller in embedded system development. It is an integrated circuit that contains a microprocessor along with memory and associate circuit and that controls some or all of the functions of an electronic device or a system. A microcontroller is a small computer on a single metal oxide semiconductor integrated circuit chip. An embedded system has a microcontroller unit that has all functional blocks available on the same chip. Coming to the block diagram of a microcontroller, it is mainly divided into three types. The microcontroller which perform bitwise operation is broadly di- classified into three types, namely 8-bit and 16-bit and 32-bit microcontroller. Based on memory devices, the microcontroller is classified into two types, namely external and embedded. In external microcontroller, the memory devices are placed externally and connected to the microcontroller via peripherals. In embedded memory devices microcontroller, all the required memory is present within the microcontroller itself, therefore not needing any external peripherals for memory interface. And the third type of microcontrollers classification is based on instruction set. Based on instruction set, we have two different microcontrollers, namely reduced instruction set computing and complex instruction set computing. Reduced instruction set computing contains a less number of instructions, therefore leading to faster execution times, but capability of handling less complex operations. Complex instruction set computing, on the other hand, will be able to handle large instructions and able to perform better, but requires lot of resource. And the next thing is fundamental aspects of selecting a microcontroller, which includes power efficiency, temperature tolerance, hardware architecture, processing power, memory, hardware interface, software architecture, and cost factor. This is the picture of PIC16F877A microcontroller. So, what is the embedded system? An embedded system is a microcontroller or a microprocessor, either of those, based system of hardware and software designed to perform a specific function within the larger mechanical or an electronic systems. Example includes our day-to-day electronics gadgets like mobile phones, laptops, etc. So the types of embedded systems. Embedded systems are broadly classified into two types based on functional requirements and based on performance of microcontroller. Based on functional requirement, it is classified into four types. namely real-time embedded systems, standalone embedded systems, network embedded systems, mobile embedded systems. Real-time embedded systems are those systems which are capable of performing operations in real time and providing results in real time. These type of embedded systems are used in critical situations where time factor is main concern. It is used in emergency braking mechanisms of vehicles and other important applications. Standalone embedded systems are those embedded systems which consists of all resource within itself. It does not require any external connections. Networked embedded systems are group of embedded systems that perform the particular action in a group. Mobile embedded systems are those systems which are able to operate individually and can be mobile as well. Based on the performance of microcontroller, we have small scale type of embedded system, medium scale embedded systems, and sophisticated embedded systems. Small scale embedded systems consist of microcontrollers of typically 8-bit type. Medium scale embedded systems consist of microcontrollers of 16 to 32-bit type. Sophisticated embedded systems consist of microcontroller of 64-bit type, which are able to perform complex calculations and operations. This is the basic block diagram of embedded systems where microcontroller is the acts as the center part of the system. It consists of it, it can it gets its input from the sensors and provides output if in the form from the actuators and indicators. LEDs are one good example of indicator. So the components of embedded system are power supply, serial communication ports, processor, memory, timers, output circuits, system application specific circuits. The tools that we used in this project are MPLab X IDE, which which is an integrated development environment, which is used to edit the code and compile the code and organize the code. And we use X8 compiler along with the MPLab X IDE and picsimlab for the simulation of the project. The components that are present in the picsimlab are first one is light emitting diode. A light emitting diode is a semiconductor light source that emits light when current flows through it. White light is obtained by using multiple semiconductors or a layer of light emitting phosphor on the semiconductor device. It is the simplest device used in most of the application as feedback. Some applications are home lighting, remote controls, surveillance, etc. LEDs in this project in the PicGenius board are connected to port B and port D. Port is a peripheral and we need to know how to access and address each peripheral. From the section of port B, it is clear that there is one more register associated with it named RISP. The RISP register is very important for input-output configuration. The value at this register would decide pin direction as shown below this table. The next important components in the board are tactile switches. In matrix keypad, we need to configure rows as output and columns as input. A tactile switch allows electricity to flow in an electrical circuit by manually pressing the operating section. The switch activates when pressed and then turns off when released. There are two types of triggering mechanisms in tactile switches. One is level triggering and another is edge triggering. Next important mechanisms are interrupts. An interrupt is a communication process set up in a microprocessor or a microcontroller. Interrupt is a signal emitted by hardware or software when the process or event needs immediate attention. It alerts the processor to high priority process requiring interruption of current working process. The MPU acknowledges the request, processes the request, and then goes back to the position where it was interrupted. Another important component is timer. They are used to keep a record of time for different events occurring in the embedded systems. The Picgenius board that we are using has three built-in timers, namely timer 0, 1, and 2, of which two timers are of 8 bit and one is of 16 bit. It maintains the timing of an operation in sync with the system clock or an external clock. These are the some of important terms related to timers, which are tick, resolution, quantum, and scaling. Another component is CLCD. CLCD is character liquid crystal display. A liquid crystal display is mode of display used in digital equipment, replacing many other modes of displays such as cathode ray tube, LED displays, and plasma displays. Most of the character LCD module used in embedded system applications. In picsimlab, we have two types of display: 16 by 2 display and 16 by 4 display. 16 by 2 display displays 16 characters in two lines and is capable of displaying 16 characters in two lines. 16 by 4 display is capable of displaying 16 characters in each line and 4 of such lines. Another important component is digital keypads. Keypads are widely used input device being used in various electronics and embedded applications. They are used to take inputs in the form of numbers and feed the same into the system for further processing. Here is a brief about PIC16F877A microcontroller. It is a high-performance RISC CPU built using CMOS technology, and it has three built-in timers and consists of five ports: port A, port B, port C, D, E, of 6-bit, 8-bit, 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 and 3-bit respectively, and the corresponding type of signals that is capable of handling by them. This is the typical overview of Genius board that we are using. It consists of onboard LEDs, digital keypad, interrupts, timers, input-output clock, SSD, CLCD, matrix keypad, and analog inputs. This is the screenshot of demo of our project. As you can see, it consists of all major components like LEDs, digital keypad, buzzer, heater, fan, which acts as a DC motor in this case, PIC16F877A microcontroller, and other important switches and CLCD. So the event procedure of this project is, as soon as we power on the device, we want the simulator to show a message like powering on the washing machine. After powering on, the simulator should show all the washing modes. Simulator should also contain matrix keypad, and with the help of its keys, user will be able to choose respective modes. In this particular design, we included a pause button that will be able to pause the time count and will turn off the device until it is released. After completing the event, time up message will be displayed on CLCD for the user to know that the operation is complete. And the different modes of operation in washing program, we have different types like daily, heavy, delicates, whites, eco cottons, rinse, dry, and other options for user to choose according to their needs. And also we can choose the water level with four different available options. So let's continue with the demo of our project. This is the UI of MPLab XIDE, and we have source files and header files. Source file consists of important functions that we implemented in our code. We create a .x file of this code after clean and building this code, and the .x file is loaded into picsimlab. This is the picsimlab that we are using. We are using PIC16 F7 F877A microcontroller and one of the PIC Genius board. So as we already discussed about the various available components in this, we are straight away moving to the demo. As soon as we start, it displays this message to press key 5 to power on the machine. So RB4 is the key 5. As we press, the it displays powering on and displays the washing programs available. We use switch 4 to navigate between the options and press switch 4 for long time to select the particular option. So I want to select stain wash. I am pressing the switch 4 for a long duration. So stain wash is selected, and to select water level, again the same tasks need to be done. Switch 4 to navigate between the options and long press to select the option. So I'm long pressing on high to select the high water level. And it displays two options, switch 5 to start and switch 6 to stop. We press switch 5 to start the program, and the timer is running as you can see. This rotating fan indicates the motor rotating, and we have buzzer here to indicate the to sound the alarm after the completion of operation or wash cycle. Here we have reset button to reset the operation if needed, and RB0 acts as a washing machine door. If pressed, the operation stops and it displays a message to close the door. Let's check it. As you can see, as I pressed the switch, the fan stops rotating and buzzer starts sounding. As soon as I released, it returns to the operation normally. So this switch acts as a door. And after completion of the operation or the wash cycle, that is when the timer returns to 0, the fan stops rotating and buzzer sound can be heard, and CLCD display will display with the message saying that watch cycle is complete and we can remove the cloth. Yeah, that is all about this project demo. Thank you for watching and thank you emertxe for this opportunity.